This is spring test number 10. This is part 2, picking up on number 26. We have negative 9 over 10 to the third power. You're going to make sure both numbers get the third power. Remember, this can be written, it might be easier to write it as negative 9 over 10. That way, just the way you know the negatives committed to one of the numbers. If you put it in front of the 10 instead of the 9, it would be the exact same thing. But they're both to the third power, so make sure negative 9 is being raised to the third power. It's an odd exponent, so it's going to be negative no matter what. Negative 9 times negative 9 is 81, and 81 times 9 again is 729. So you have negative 729 over, and then 10 times 10 is 100 times 10 more is 1,000. And that's a simplified answer. There's no number that's going to go into both of those. Okay, then we're going back a whole bunch right here. Just to remediate you a little bit. 1/6 times 3 over 10. This is not addition and subtraction. It's okay for the bottom two numbers to be different. You can do this one of two different ways. You can multiply straight across. 1 times 3 and get 3, and 6 times 10 and get 60. And then know that the number 3 goes into both of them. It goes into the number 3 one time, and 3 goes into the number 60 20 times and get 1 over 20. An easier way for some people to do it is to realize when they're looking at the original expression that the number 3 goes into both the number 3 and 6. It's called cross canceling. It goes into itself one time, and it goes into 3 times 2 is the number 6. So if you multiply straight across now, you get the same 1 over 20. It looks like addition on you guys' paper, so make the correction. It's actually division for number 28. So 1/2 divided by 5 over 9. Remember, division is the same thing. You flip it, you multiply it by the negative reciprocal. I'm sorry, you multiply it by the reciprocal. I'm getting confused with perpendicular. Multiply by the reciprocal. So what you want to do is leave the first fraction just like it is, 1/2. Change division, change it into multiplication, and flip it and make it, instead of 5 over 9, make it 9 over 5. Now multiply straight across. 1 times 9 is 9. 2 times 5 is 10. No number that goes into both of them. 29, going way, way back on this one. Find the greatest common factor. Greatest common factor. The easiest way to do greatest common factor, or a shortcut method, is always to take the smallest one and see if you can multiply the smaller one, or the smallest or the smaller one, by 1 and get the bigger one. Notice that 23 can be multiplied twice to get the number 46. So actually the greatest common factor of both of these is the number 23. But if you can't see that, go ahead and factor out 23. Its factors are 1 times 23, and that's actually it. There's no other numbers. It's a prime number. 46's numbers are 1 times 46, and 2 times 23. So you can see the factors if you do it that way. You can see that this one's largest factor is 23, and this one is 23. Greatest is the same thing as largest. Common means they have the same one. Next one, 118, 72, and 117. Again, take the smallest one and see if you can multiply it by something and get the largest one. 18 does not go into 117. Actually, it'll give you 6.5 if it does. So we need to find another number, and usually using the smallest number, it'll give you one of them. So 1 times 18, 2 times 9, 3 times 6, and that's actually it. There's no other number. So it's going to be one of those numbers will be the greatest common factor. We already know that the number 18 won't go into it, so what we want to do is we want to try the next one and see if we can multiply 9 by something. We know we can multiply 9 by 8 and get 72. We want to see if we can multiply 117 by something, by 9, and get a number. The easiest way to do it is to go ahead and do 117 and divide it by the number 9. 9 goes into 11 one time, and there's 2 left over, and 9 goes into 27 3 times. So yeah, the 9 goes into all three of these numbers. 9, 9, and 9 are factors of all this. So the greatest common factor, and I know I'm all over the place with my writing, your greatest common factor for number 30 is 9. Least common multiple for the next one is way easier for most people to understand. The only problem people have is they get them confused which one's which. Multiples of something, or think of when you multiply it, like it counts up. Multiples are great big numbers. They count up. So 6, 6, then 12, then 18, then 24. Those are multiples. All we're doing is counting by 6 for those. 22, we want to find out where we're going to match up with them. We want to find out where they're going to sync up, which one's going to be the same. So 22, then 44, then 66, then 88. It's going to keep doing that. So we want to find its least common multiple. We hadn't gotten there yet. With the bottom one, we actually did. Because when you multiply 6 times 11, you're going to get the number 66. 6 times 11. Had we kept counting, we would have gotten to the number 66 there. So the least common multiple is 66. Thirty-two says write the number in scientific notation. Remember, scientific notation needs to be from numbers 1 through 10. It's got to be from 1 through 10. So 26,900,000 is way too big. And you can't move the numbers. All you can do is put the three numbers 2, 6, and 9 and find out where the decimal is going to be in regards to those. The only spot it can be is right here. If we put it between the 6 and the 9, then that'll give you the number 26.9. That's not between 1 and 10. So you have to move the decimal. You have to find out it starts here, how many times you have to move it. You move it 3 times to get through this comma. You move it 3 times to get to the next comma, and then you move it 1 more. So that's 3 plus 3 is 6 plus 1 more is 7. So we moved it 7 times. It's a big number. So 2.69 times 10, it's a big number, so it's the positive 7th power. That's scientific notation. Number 33 is doing the opposite. We're moving it back to standard notation. Remember, anytime you have a negative exponent like this, that means it's going to be a smaller number than what's represented. So you have 6.47. A positive exponent is a much larger number. A negative exponent is a much smaller number. So we don't want to move the decimal over. We only want to move it 1 time, but we don't want to move it to the right because that'll give us 64.7. We want to make it a smaller number. So we want to move it 1 time to the left, which gives us 0.647. Had it said 10 to the negative 2, we would have moved it twice to the left. Negative 3, we would have moved it 3 times to the left. But that's standard notation. Number 34, you have to multiply 8 times 6. 8 times 6 gives you the number 48. That's just the two coefficients, if you will. And then you have the same base multiplying by each other, 10 and 10. In that case, it's 48 times 10 to the 7 plus 3. Remember, same base means add the exponents. So you have the number 48 times 10 to the 10th power. But 48 is not scientific notation. It says write it in scientific notation. This is almost scientific notation, but 48 has to be, that number 48 has to be between 1 and 10. So you can't change the number 4 and the number 8. You can just change where the decimal is. It's right after the number 48, so we have to move it 1 more time to the left. When you move decimals over to the left when you're creating standard scientific notation, your number actually goes up 1 more because it's a bigger number that's being represented by a smaller number. So 4.8 times 10, but instead of to the 10th, we have to move it over. It has to go up 1 more. So it becomes 10 to the 11th. Number 35 is finding a solution to the following system of equations. Okay, you have different methods you can use. You can use the substitution method, or you can use the elimination method, or you can graph them, which is probably the least preferred method. if we go with our least common multiples, since we have a negative 5x and a positive 2x, the smallest number that both 2 and 5 go into, their least common multiples, if you look at them, 2, 4, 6, 8, 10, and 5, 10. The least common multiple would be the number 10. So we want both of them to become the number 10. So take that first equation and multiply the 2 by whatever number it has to be to become 10. So multiply it by 5. But you can't just multiply the 2 by 5. You have to multiply everything by 5. 5 times 2x is 10x. 5 times positive y is plus 5y. And 5 times negative 4 is negative 20. So we got 10x there. We want the x at the bottom to be negative 10x. So it's already negative 5. So we need to multiply it by 2. When you multiply 2 times negative 5x, you get negative 10x. That's what we were looking for, but you can't just leave it there. It's got to multiply by 5y to get a positive 10y, and it's got to multiply by 10 to get a positive 20. So when we take these two and we go ahead and we combine them in order to eliminate them, 10x minus 10x, when we put those two together, we get 0x's. They eliminate each other. When we put 5y and 10y together, we get 15y. And we put negative 20 and 20 together, we get the number 0. So when you have 15 times y, you undo that by dividing by 15. Do the same on the other side. And y equals 0. So y's value is 0. Take one of the equations, go with the first one more often than not, and plug in the value. So 2x plus y equals negative 4. In place of y, since our number is 0, we want to plug in 0. 2x plus 0 equals negative 4. So 2x plus nothing's negative 4 is the same thing as 2x equals negative 4. Get rid of 2 times something by dividing by 2. Do the same on the other side. X's value is negative 2. So you have your x value and your y value. Remember, they're written as x comma y as an ordered pair. So negative 2 comma 0 is your ordered pair. That's the solution. If we were to graph both of those equations, they would intersect at the point negative 2, 0. Then number 36 says graph the inequality. This is in mx plus b form. So it is showing you a slope and it is showing you a y-intercept. B is your y-intercept. B tells you where to begin. Its value is 1. This is your y-axis. So begin where its value is positive 1. Your m value is negative 5. Remember, m is always a fraction. So if it's not showing it being over another number, put it over 1. That tells you to go down 5 times and go to the right 1 time. So from the place where you began at 1, you go down 5 times and to the right 1 time for your second point. Had this been just an equation, we'd write a line through it and we'd be done. But this is an inequality, and it is greater than. It's not or equal to. Therefore, we don't put a solid line. We put a dashed line going through the 2 points. We have one more thing to do. We either need to shade everything here or we got to shade everything there. You can't just guess. We have to determine which one it is. Got to determine which one it is. Your line does not cross through, even though it looks like it gets close. It does not cross through the point 0, 0. So we want to use that point by plugging it in. Its value is 0, 0. That means its y value is 0, and so is its x value. So in place of this equation, plug in 0 in place of y is greater than negative 5 times 0 in place of x plus 1. Anything times 0 is 0 here plus 1, and 0 is greater than 1. You have to evaluate this statement. That's not true. 0 is not greater than 1. Therefore, everything over here is wrong, so you have to represent the other side as being a correct side. And then the last one, number 37. The last one's a little hard for you guys to see, but it is a solid line, and it is shown going that way. What you need to do is you want to find y equals mx plus b form for this one. So mx plus b is called slope-intercept form. So you need to have a slope and you need to have a y-intercept, or you need to have a beginning point. You can see it crosses through the y-axis at 4. So your b value is 4. Your slope is how many times it rises over how many times it runs. So how many times it goes up or down over how many times it goes left and right. So from that point, pick you another point that's on an intersecting line, like where it's not going through the middle of two lines. It goes down one into the right one. So down one is -1, into the right one is 1. So your M value is -1 over 1, which is the same thing as -1. So you have your M value and you have your B value. You can write your inequality based on that. Y equals mx plus b. You'd write it as, that would be your equation. Y equals -1x plus 4. But it's not an equation. It's an inequality. So we have to determine if it's less than or if it's greater than. What we want to do is we want to pick the point 0, 0 since it's not going through there and plug those values in. 0 is going to be something. We don't know if it's less than or greater than -1 times 0 plus 4. Again, 0 is something. Anything times 0 is 0 plus 4. And then 0 for the last part. 0 plus 4. 0 is something 4. Then you have to, based on this, we're going to say it's less than or greater than, based on that, if we want a true statement or not. Notice we're shading to the same side as 0, 0. Since you're shading to the same side, that means it's true, 0, 0. Therefore, we want a true statement. So in order to have a true statement, we have to say 0 is less than the number 4. So we go back to our equation that says y equals -1x plus 4. It's going to be y is less than -1x plus 4. And then you have one more check you have to do. Do I make it less than or equal to, or do I leave it alone? It's a solid line, and a solid line means make it less than or equal to. So y is less than or equal to -x or -1x plus 4.